Hello everyone. Today I'm going to discuss about the synthesis of ibuprofen. So we know that ibuprofen is a non-steroidal anti-inflammatory drug. So the starting material for the preparation or synthesis of ibuprofen is with isobutyl benzene. So this is benzene. So I will attach an isobutyl group. Okay. So this isobutyl benzene is subjected for Friedel-Crafts acylation reaction in the presence of acetyl chloride. Okay, so isobutyl benzene reacts with acetyl chloride in such a way that, so this chlorine, as it is highly electronegative, it gets negative charge, and one of the hydrogen atom from isobutyl benzene combines with Cl minus to liberate HCl as a byproduct. Okay, so this is an example of Friedel-Crafts acylation reaction in the presence of Lewis acid AlCl3, so which acts as a Lewis acid. Okay, so what is the product intermediate compound you are going to get here? The same isobutyl group you can write. Here it will be C double bond O CH3, because one of the hydrogen and chlorine has removed in the form of hydrochloric acid. So this is a perfect example of Friedel-Crafts acylation reaction. Next, this intermediate compound will undergo nucleophilic addition reaction in the presence of hydrogen cyanide. Okay, so initially what happens when you compare the electronegativity profile between carbon and oxygen? So definitely oxygen will have more electronegativity. So this pi bond will migrate towards oxygen atom. Therefore, this carbon will get electron deficiency. Okay, now when this pi bond is migrated towards oxygen, oxygen will get additional one more lone pair of electron. So here hydrogen cyanide will also undergo dissociation to form H plus and Cn minus. Okay, so this Cn minus will migrate towards the positively charged carbon, and this H plus can be stabilized by using this extra lone pair of electron which is present on oxygen. Therefore, you will get the same benzene ring, okay, isobutyl group followed by C single bond. As you transferred one pi bond towards oxygen, you will be left over with single bond oxygen OH. Okay, followed by Cn. Next, CH3. Okay, so this is a perfect nucleophilic addition reaction where the addition of hydrogen cyanide has been completed. Okay, so in the last step, so this is a cyanohydrin derivative. Okay, so this cyanohydrin derivative is initially subjected for hydrolysis followed by reduction. Okay, so when cyanides undergoes hydrolysis, you will get corresponding carboxylic acids. Similarly, it is also undergoing reduction process in the presence of hydroiodic acid and phosphorus. So reduction is nothing but the removal of the oxygen atom. Okay, so you will get carbon. So when cyanides are subjected for hydrolysis process, you will get carboxylic acid. And when it is subjected for reduction, oxygen will be removed and hydrogen will be there as such, followed by CH3. So this is a basic structure of ibuprofen. Okay, so ibuprofen can be synthesized from isobutyl benzene reacting with acetyl chloride. Okay, so as chlorine is more electronegative, it will leave the reaction with negative charge. And one of the hydrogen atom in isobutyl benzene combines with Cl minus to remove HCl. Okay, so you are going to get one intermediate compound. This compound further undergoes nucleophilic addition reaction in the presence of hydrogen cyanide. So here what happens when you compare the electronegativity between carbon and oxygen, this pi bond will migrate towards oxygen. So oxygen will get 3 lone pair of electrons and carbon will get electron deficiency. Since you are using hydrogen cyanide, it will undergo dissociation process to form H plus and Cn minus. So this cyanide ions migrates towards the positively charged carbon, and oxygen, it is having one extra lone pair of electron, it will be transferred to hydrogen. Therefore, you are going to get OH and cyanide group attached with the carbon atom. This is cyanohydrin derivative. So this cyanohydrin derivative, initially it is subjected for hydrolysis process where the cyanides will be converted into carboxylic acids, followed by the same cyanohydrin derivative subjected for reduction process. So oxygen can be removed, hydrogen will be left over here, and the so-called structure, that is nothing but ibuprofen, which is a non-steroidal anti-inflammatory drug, which has antipyretic, anti-inflammatory, and analgesic activities. Okay, so this is about the synthesis of ibuprofen from isobutyl benzene. Thank you.